Here is a tick that's been sputtered with copper. It's kind of spooky. I realized I hadn't made a video yet about my scanning electron microscope, and I've been posting pictures I got from it all over my blog or website recently, and I wanted to make a quick video where I show the setup and basic operation of this microscope. So this is that. This is a JEOL JSM 6300 scanning electron microscope. I picked it up on eBay a couple of months ago, and for the past couple of months I've been setting it up and learning how to use it, and it's been really fun because I didn't know really anything about this just a couple months ago, and now I'm able to operate it and get really basic images. So I'll give you a quick tour of it now. So this is the main console. On the left here, there's an analog CRT monitor, and on the right displays the digital images that are required. And below it are all the controls for magnification, focus, the stigmator, all kinds of scan settings, and down here you can switch between the secondary and backscatter electron detectors, all kinds of other things. This is what you use to saturate your filament. And there's a couple of keyboards. There's a computer built in here, and there's also this other computer out here that runs Windows 98, and this has the digital capture software and stuff on it. That's pretty fun. The image capture from the day, 1996, thereabouts, was this Polaroid camera here, which is pretty awesome. There's a CRT down here that fires upward, and you're supposed to put Polaroid film in here, and it scans the beam across and will expose a Polaroid sheet. On top of the console here, I have a Tektronix waveform monitor, so I can just center the NTSC analog video. On oscilloscope, I was playing around earlier with measuring the probe current, and this is my really high-tech vacuum meter. So this is wired in. The column over here has 3 Pirani gauges on it, so I tapped into one of them, and I can just get it's not accurate, but I can get a quick visual on whether we're at atmosphere pump down or somewhere in between. And pump down on this is about 1 × 10⁻⁴ torque, because this is a diffusion pump based machine. If you add the big manual, which I couldn't have got it working without. Around back of the console, you'll see all the wires and everything I had to connect to get this thing running. So there's a ton of unlabeled and crazy cables, and luckily I had a wiring diagram, so I was able to figure out what different circuit boards and things do. But it really is a rat's nest back here. This is the 30 kV power supply for the filament. There's a high tension cable that comes out of it, and this is all immersed in transformer oil. I had to replace that. That was fun. And this is the column here, so this is the actual microscope. The whole thing is under high vacuum right now. The top part here has a little cap. This will pop open, that's where your filament goes. So this is the electron source, and the focused electron beam gets shot down here. There's tilt and shift coils, as well as focusing and stigmation coils, and there's an aperture right here, which consists of a very small piece of foil with small, like 50 micron-ish holes in it, and you can adjust and center that. And there's a gate valve here that separates this column from your specimen stage. And this thing is pretty cool. You can put up to a 6-inch specimen in it, which is quite huge, especially for this being in the 1996 era. You can draw out this entire thing. It'll slide out. It's on like little desk chair wheels down here. And you can put a 6-inch sample in, or you can put a smaller sample in through the it's a load lock or an airlock in the front here. So I'll show you that in a bit, and that's a really nice feature. It saves a lot of time. This down here is the backscattered electron preamplifier. This is the secondary electron detector, and these are motorized XY manipulators that go down to a micron. These are very nice. There's stage tilt and rotation and all kinds of other adjustments around there. This is the evacuation manifold, so this is what evacuates this area down to high vacuum. This is one of those Pirani gauges I was talking about, so I tapped into one of those on that multimeter. Requires a nitrogen cylinder, that's right here, and that does, there's all kinds of solenoids and stuff in here, and it also, when you bring the chamber up to atmosphere, rather than just letting air go back into the chamber, it can control that with the nitrogen, and it's also much, much cleaner. This is the rotary mechanical pump, and that goes through a vibration isolator down here, which is like a big heavy brick, and then that goes into the back of the machine. I have the side panel off here so you can see the inside. There's one of the diffusion pumps here, there's one right here, and then one in the back there, and it's a mess in here as well. Up there, there's a 10-liter vacuum reservoir, which allows you to pump down the little airlock thing there really, really quickly, which is nice. And the diffusion pumps are water-cooled. I'll show you the chiller in a few minutes. And this is the back of the vacuum control board, which I'm having some issues with, so I have the front panel off as well. This thing is supposed to automatically control the vacuum system, so when you turn the microscope on, it should rough the main chamber and then evacuate it down with the diffusion pumps automatically. But it's having some issues, so I have to do it manually by flipping all these switches and looking at this cool diagram here. So that's a little bit annoying, but it's not that big of a deal. That's everything down here. The water chiller, which I'll show you in a second, needs a water supply of its own because it's basically a heat exchanger. So I had these copper pipes here plumbed, and they go all the way up to the ceiling and all the way in the back to the sink. So behind the microscope, under this bench here, there's an electrical panel right here, and this is a main shut-off, and then a 30-amp breaker for the microscope and a 15-amp breaker for the chiller. This is a power supply. This thing has 3 big transformers in the bottom, and I had to change the taps on this, so it takes 240 volts in and makes 200 volts and 100 volts and all the other weird power that the microscope needs. It's a Japanese machine. And this is the chiller right here. It'll do something like plus or minus 0.1 of a degree C per hour or something like that, and it flows about 5 liters per minute. It's got a digital temperature readout on the front, which is nice. It's a pretty nice unit. And that's basically everything for the microscope. So now I'll go through the setup procedure and get it running. We can look at a couple samples. First thing I need to do is go to this panel here and hit the main breaker. Next thing I'm going to do is walk over here and turn the nitrogen cylinder on. It had pressure in the lines from last time. Now I'm going to walk to the other side of the shop by the sink, and this is the water supply line for the chiller. Now that's on. We can go back, and then I'm going to start up the chiller. It's going to get a little bit noisy. The chiller runs water through the diffusion pumps, and also in the back of this console here there's a bunch of electronics that are water cooled. So this is an interlock switch for the chiller. Now that's on. I want 68 degree water, which is about 20 degrees C. Right now we're at 66 degrees, so that's going to come up. And we can see over here that we're at 5 liters per minute, just like I want. So now that we have the power on, the water chiller, and the nitrogen on, we can go ahead and turn the actual microscope on. Down here there's a little key switch, just like starting a car. You put it on the on setting and then flip it to start. And the CRTs are slowly going to come on. You heard the rotary pump just come on, and some lights are turning on down there on the vacuum control panel. So things are happening. The first digital CRT is coming on. I'm going to boot up the Windows 98 computer at this point. That takes a little while to go. I'm going to turn this guy on, and our vacuum gauge just turned on, so it pinned the meter, and that's going to center down in a minute, and it's going to be somewhere around here, because when I last used it, it was pumped down, and then it leaks up a little bit, but we're not quite at atmosphere, so in a minute here that's going to come down. That's not a real reading. So I want to show you how to load a sample the cool way. The less interesting way is using this thing here. You'll load your sample onto a sample holder or a pedestal like this, and the end of this rod will thread into it, and the rod will be inserted into the microscope like that. The airlock will be evacuated, and then you push this red ball all the way in there, and then you unthread the sample, so the sample stays in there and you can retract this and pull it out. but I want to show you the whole inside of this. So I have to bring this up to atmosphere, and then it's going to slide out. So to do that, we go down here on the vacuum control, and we can vent the gun or the specimen chamber. I'm going to vent the specimen chamber. So I'll hit that. Valve LV3 will open. That flows nitrogen into this chamber, and then in a couple minutes I'm going to be able to draw that out. The computer's booting up here. There we go. Alright, this guy's ready to be drawn out. This is the stage here. The sample will sit right here, and this is the XY table. That's the connection to the diffusion pump with that screen there, and you can see up there is the backscattered electron detector, and then to the right of that is, you can see the Faraday cage on the secondary electron detector. Now we can put a sample in. So I have this one prepared already. This guy has a ton of things on it. It's got a bunch of bugs and stuff. I hope you can see that. Not really. So this has got a bunch of bugs that I've sputtered. So they're conductive, so you can look at them under the microscope. It's also got a light bulb filament, a really, really tiny gallium arsenide, high electron mobility, RF transistor FET, and some really small medical chains and devices and cool stuff like that. So, I'm going to come over to the microscope and just slide it on here. Make sure it's seated. And now I can close this. And if everything was working perfectly, I would be able to depress this button and the chamber would automatically vent itself, but it's not working. So instead of doing that, I have to come to the vacuum panel here, and I have to initiate the roughing sequence manually. So I have to flip switches V1B, V4, and V6, and then flip it over to manual. And now that's going to suck in. I'm just holding it there, and it grabbed. So now this chamber is being roughed down by the mechanical pump, and we'll see the needle on the vacuum gauge start to come down in a minute. And I'll come back when that's roughed down to the point where I can start the diffusion pumps. The diffusion pumps are being heated right now. The heater is not all the way warmed up, indicated by that light. And then I'll come back then, and we'll turn on the diffusion pumps. Okay, the system has been roughed down, so when I'm in here I'm going to connect the diffusion pump. To do that, I'm going to close valve V6 and V4, and I'm going to leave V1B open and open V1A and V2, and that's going to rough down for a couple minutes, or rather evacuate to 1E-4 for a couple minutes. It really doesn't take that long. Then once that's done, I will open V7, which is the gate valve between the gun and the specimen chambers, and then I can turn my electron beam on, saturate the filament, and we can start getting some images. Something that I can do, which is pretty nice, rather than redoing all of the settings for gun alignment and everything like that every time I turn the computer on or turn the microscope on, I can load and save the SEM parameters. So this is from a couple days ago, and I can load that onto the microscope. These are all my settings. And it's going to start loading in here on the computer. It just saves some time. I'm waiting for it to pump down, and I got bored, so I thought I'd show you how I prepare the samples. This is my high vacuum chamber, and right now it's set up for sputtering. So over here I have some gases. I can flow argon into the chamber via the mass flow controller very, very precisely. And, well, first I evacuate it with the turbo pump over there, and then once the blades in that slow down, I can allow argon back into it and make whatever partial pressure of argon I want. And inside of it, I have right there that big stainless plate there is where you put the sample you want to coat, and on top I have a plate of copper, and that's the target that gets sputtered down onto it, and big electrical feed-throughs down here. Those wires are too small for sputtering right now. I have it set up to do plasma cleaning. My sputtering supply actually burnt out, so I'd come over here, and the pressure is too high right now, so I can't sustain the plasma, and there's going to be some arcing in the chamber, but I can just go like this, and turn that on to a few hundred volts, and you can see there's a plasma in the chamber. We're all pumped down, so I can go ahead and turn the acceleration voltage on now. When I turn that on, it's at the 20 kV right now. When I turn that on, this meter here is going to come up, and that's showing the emission current from the filament, and I'll click this and it'll show the forward current that we're sending to it. So I just turned on the acceleration voltage and the filament voltage and everything else, and you'll see up on the waveform monitor we actually have an image. So without even touching anything else right now, I can adjust that in brightness and contrast, and we can see an actual image of what's going on in the chamber. So I'm not going to touch that right now. I'm going to quickly make sure that the filament is saturated, and right now we're putting around about 70 microamps out, and I'm going to make sure that's saturated, and I'm going to align the gun for tilt and shift and a couple of other things, and then we'll be ready to go. In the tungsten filament, as you go to saturate it, there'll be a first peak and a second peak. When you're doing critical work, you want to run at the second peak. It'll give you higher resolution, but your filament will burn out faster. So I'm going to get the first peak right now for lower clarity, but we're just messing around here. It's not like it actually matters that much. This is a very, very quick setting right there. Alright. Let's just bring it in a little bit closer here. And you can see what's going on. So these are all of the parts that are inside of it. The computer has an awesome function where using this ball mouse here, when you're under the right menu, you can use it to actually move the stage. So watch these manipulators, and then move the ball mouse around. It's a pretty useful feature. So we can look around, and I'll find some cool stuff to look at. I'm sorry for these artifacts on the screen here. It's kind of hard to film CRTs, but anyway, this is the light bulb filament. I have it centered up on here. These are the two wires. This is a little glass bead insulator. Slide down and see that. And then I can just pop right in. And the background you're seeing here is the double stick tape I used to prepare the sample. It's conductive carbon tape. These images are quite low quality because it's a very fast scan that's going on here. Does that look better? Yeah, it looks a little bit better. So you can actually see, even in these lower quality scans, you can see lines across the tungsten filament, and those are actually the tooling imperfections and the dullness of the tool that they used to create this this filament. So if I wanted to get a higher quality image, I would then do a little bit of a slower scan, and then it would integrate over multiple passes with the electron beam, and you get a much higher resolution image. So that's pretty neat. I'm going to go back to a fast scan. I'm going to zoom out a little bit, and I'm going to slow scan that again. And then when I'm happy with the image, I can then send it up to the digital computer, and then I could then export it to a more modern computer. So I go to the imaging tab and hit receive, and it'll freeze the digital monitor there, and it'll send it over via SCSI cable to the ancient computer. And there we go, we have the image. I'm going to learn auto brightness contrast. We can look around it, it's pretty cool. And I can even measure. So let's just see this, the rough diameter of the wire is roughly 36.86 microns across. And the diameter of the overall winding, roughly almost 200 microns across it. Here is a tick that's been sputtered with copper. I know, it's kind of spooky. Yeah, there you go. It's pretty scary. This is a poppy seed. Looks pretty neat. And here's the leg of some insect. It's a pretty large insect. I don't really know what it was though. Yeah, those are the hairs on the leg of some insect, which I don't know. Yeah, there you go. Pretty neat. Now, if I wanted to actually grab really high-resolution images, there's a few things I would do. So the first thing I would do is I'd put the filament at its absolute saturation, so at the second peak. I would go over to the aperture right there, and I would close that in. Right now we're at aperture setting 3, which is a pretty wide aperture. So I would close that in, and that would physically give us a smaller electron beam. Then I would lower the probe current, which further gives you a smaller beam. I would make sure the acceleration voltage is maxed out at 30 kV. Then I would redo a gun alignment for tilt and shift, and I would also center the aperture by engaging the wobbler here, and it's actually pretty well centered right now. So that's all for my scanning electron microscope video. Please check out my website. I'm posting a lot more pictures from this, and I'm really having a lot of fun with it. So thanks for watching, and I hope you learned something. And if you do decide to grab one of these for yourself and put it in your garage, best of luck, and have fun searching around eBay.